Welcome. Have you ever stopped to think about how that sandwich you had for lunch is powering your brain right now? Today, we're diving into your body's amazing energy economy. Seriously, it's a system more complex and efficient than anything on Wall Street.
Brunch. Buffet. Now, what on earth do those two fantastic words have to do with biology? Well, it turns out they're the perfect way to think about our body's two main settings, feast and famine. How our body deals with that all-you-can-eat situation is really the key to understanding its entire energy game plan.
And that entire game plan, that whole strategy, it all boils down to one word: metabolism. And it's so much more than just burning calories. It's a constant, high-wire balancing act happening inside you every single moment of every single day.
So, the official definition of metabolism is the sum of all the chemical reactions in the body. But what does that actually mean? I want you to picture the nearly 40 trillion cells that make you, well, you. Inside every single one of them, right now, there's this incredible, chaotic symphony of reactions breaking things down and building other things up, all just to keep the lights on.
And this chemical symphony really has two main sections. On one side, you've got catabolism. These are the breakdown reactions. So think about digesting that brunch buffet. Big food molecules get broken down or catabolized into smaller pieces, and that releases energy. Then, on the other side, you've got anabolism. These are the buildup reactions. Anabolism uses that energy to construct bigger molecules, like when your body uses protein to build new muscle. One breaks down to release energy, the other uses that energy to build. It's a perfect partnership.
Okay, so catabolism is breaking stuff down and releasing all this energy. But then what? How does the body actually grab and use that energy? It can't just have these random explosions of power floating around. It's got to have a way to manage it all. Kind of like how an economy needs money.
And this, right here, is our body's universal currency. It's called ATP, which stands for adenosine triphosphate. If a cell needs to get any work done, I mean anything, from making a muscle contract to firing off a thought in your brain, it has to pay up. And the only currency it accepts is ATP.
Now here's the really brilliant part. An ATP molecule works just like a tiny rechargeable battery. When it's fully charged, it's holding energy in its chemical bonds. When a cell needs that power, pop! It breaks off one of those bonds, the energy is released, and the ATP becomes a partially used battery called ADP. Then, the energy we get from our food is used to stick that piece right back on, recharging ADP back into a full ATP battery. It's this endless, incredibly efficient cycle of spending and saving energy.
So we know what recharges our little cellular batteries, but how? How does a bite of an apple actually become the ATP that's powering your thoughts right now? Let's follow the journey. The whole process is called cellular respiration, and it's basically how we get energy from our food. Things like bread and fruit get broken down into their simplest form, which is usually glucose, a simple sugar. You can think of glucose as the main raw fuel for our cellular energy factories. Now, this whole energy factory runs in three main stages. First, a process called glycolysis literally splits a glucose molecule in half. Next, those smaller pieces head into the cell's power plants, the famous mitochondria, for the citric acid cycle, where they're broken down even more. And finally, in the grand finale, the electron transport chain uses the oxygen you're breathing to just pump out a massive amount of ATP. And the payout here is just enormous. From one single molecule of glucose, this whole process can crank out around 30 to 36 molecules of ATP. To give you some perspective, that's an energy efficiency of about 40%. That absolutely blows any engine humans have ever built right out of the water. It's just an incredible return on investment. Okay, so this system is fantastic at generating energy. But what happens right after that big brunch when you've got way more glucose than you need? And on the flip side, how do you not just, collapse from lack of energy a few hours later between meals?
The answer lies in our body's amazing ability to switch between two different modes. You've got the absorptive state, which you can just think of as the fed state, and the post-absorptive or fasting state. Your body just flawlessly switches between these two all day long, using different hormones to manage whether its main goal is to store energy or to release the energy it already has in storage.
So let's look at that fed state first. Right after a meal, glucose is flooding your bloodstream. Your pancreas senses this and releases the hormone insulin. Now, insulin acts like a key. It goes around to your cells and unlocks the door to let glucose inside so they can use it for energy right away.
And for any extra glucose that's left over, insulin tells your liver and muscles to pack it away for later as something called glycogen. It's kind of like putting your extra cash into a savings account.
But then, a few hours later, when you're in that fasting state and your blood sugar starts to dip, the whole system flips. Now the pancreas releases insulin's counterpart, a hormone called glucagon. And glucagon's message is simple: release the reserves. It tells the liver to break into that glycogen savings account and release that stored glucose back into the blood. This makes sure your brain, which is a total sugar hog, always has a steady fuel supply. So, we've gone on a journey from a brunch buffet all the way down to the inner workings of our cells. What's the bottom line here? Why does understanding this incredible energy economy actually matter to you in your day-to-day life?
Let's just break it all down. At the end of the day, your body is an absolute master of energy management. Your metabolism is this constant, beautiful balancing act between breaking stuff down for fuel and using that fuel to build you up. The whole show is powered by ATP, that universal energy currency for life, and it's all flawlessly directed by hormones like insulin and glucagon, making sure you have the energy you need exactly when you need it. Which really brings us to the final thought here. We've seen just how brilliantly designed this system is. It can handle feasts, it can handle famines. It can turn a simple sugar into the power for every single thought and every single movement. The system itself is nearly perfect. So the real question is, are you giving that incredible system the right fuel to do its job? Something to think about.